Hello everyone, and I hope that you're doing well. Today we're doing another BGCSE past paper, and we're doing a chemistry paper 2 from the year 2022. Please remember, before you start the examination, always write your school number, write your candidate number, write your surname, and also your initials. As always, please read through the instructions carefully, and if you should have any questions or queries, please clarify those with the examiner before you start the examination. They will also provide you with a periodic table and you could use it when needed. So let us jump into question number 1 at this time. And question number 1 reads that use the periodic table to answer the following questions. Part 1 is to name the group which contains elements that normally have an oxidation number of -1. And so what this means, we're looking for the group of elements that will gain 1 electron. And group 7 elements, those are the elements that will gain 1 electron to become a -1. For part 2, it said what determines the order of elements in the periodic table, and the number of proton determines how elements are arranged in the periodic table. Point to note that the number of proton is also equivalent to the atomic number. For part 3, it said name the element located in group 2 and period 4, and this element is calcium. So what I did here is to show you the electron configuration, and so if it is 2882, then it means it has 2 valence electrons, and elements are placed in groups based on the valence electrons. There are also 4 shells, so each number represents a shell, and so since it has 4 shells, it is also in period 4, because elements are placed in periods based up on the number of shells. Now let's look at part 4. It says using your answer in 3, state what type of element it is. And so calcium is a metal from group 2. Once it has 1, 2, or 3 valence electron, it is a metal. So in this case, calcium is a metal. And to be very specific, since it is in group 2, then it is an alkaline earth metal. That's a very specific answer there. Part 5, name a liquid metal at room temperature, and this is mercury. Part 6 is a name a metallic element that is alloyed with iron and stainless steel, and this could either be chromium or nickel, because both of them will be in stainless steel. For part 7 is a state the chemical formula for the gas that makes up 78% of the atmosphere, and this is nitrogen. For part 8, it said X is an element in group 2, Y represents an element in group 7. Write the chemical formula for this compound. And so to show you the working here, if X is from group 2, then it will be a +2, and if Y is from group 7, it will be a -1. And so what they do is to cross down the valences, and so we need here 1 atom of X, and this means we need 2 atoms of Y. Hence, the formula is XY2. For part 9, is a state 2 properties of the compound formed by X and Y. And if X is a metal and Y is a non-metal, then the compound is an ionic compound. And so, therefore, the compound XY2 actually, it will have a relatively strong bond. The boiling point and melting point will be relatively high. It will be hard and brittle. It will be crystalline solid, soluble in water, and also an insulator in the solid form. And so these are some of the basic properties of ionic compounds. And so it will be same as for XY2. All right, so question 1 is out of the way. Question number 2. Question number 2 states now a student was conducting an experiment in an attempt to determine the amount of dissolved substances in seawater. The diagram shows the masses found before heating and after heating. And so if you notice, the masses are different. The before mass is higher than the after mass because something is missing from that solution. We're going to talk about that shortly. And so the first part of the question asks us now to name the apparatus labeled A, and this is an evaporating dish. All right, so let's go to part 2. It said name the substance that make up the majority of the solid left after all of the water has been removed by heating. And of course, the mass is different because water now was evaporated. All right, so the evaporation of water leads to a decrease in mass. All right, so the solid that left behind, the majority of that solid will be sodium chloride. And so sodium chloride is NaCl, that is the salt that remains from the seawater. For part B, is that the table shows data from the students' experiment. And so they break down in terms of the different apparatus and substance. So you have the mass of the apparatus A plus the solution, mass of the apparatus A, mass of the apparatus A plus the solid, mass of the water, mass of the solid, and they give the masses here. And so the first thing it asks us here is to complete the table. And so to find the mass of the water, because water will be a part of the solution plus the solid, right, which is the sodium chloride. And so to get this, what you want to do is to minus the mass of the apparatus A and the solid from the apparatus and the solution. And what you'll get here is the mass of the water. So, and see the working in red on the right. And so to find the mass of the solid, it is quite easy and obvious in this case because you have the mass of the apparatus A plus solid. So all you need to do is to minus the mass of the solid from that. And so you'll have the 36.93 minus 25.64, which gives us 11.29. And these will be in grams. All right, let's go to part 2. So part 2 now, we say a student wants to obtain pure water from another sample of seawater. Identify another method of separation that can be used. And so in the first example, the student wanted to get the solid, so he used evaporation technique. Now to get the pure water, what you're going to use is a distillation technique, particularly simple distillation. All right, and that's just being specific. All right, let's go to part C. It's a part C now. It's the kinetic theory gives scientists an opportunity to describe how particles in various states of matter behave. And so part 1 asks us now to discuss the arrangement and movement of particles in a gas and also in a solid. And so the movement in gas, the particles will move fast or rapidly. And this is due to high kinetic energy. You do not need to explain why, you just need to tell the movement, and the movement is very fast or rapid. So that's the mark. So notice here is a total of 4 marks, and so for each of this is just a mark. But of course, I'm gonna give you a little bit of information extra, sometimes. Now arrangement. For the arrangement now is that the particles are far apart. That's what is in gas. The particles are far apart. That's it. And I just say that they're far apart from each other, and then the particles also spread out to fill any available space. Now for movement, for solid, is that the particles only move about their fixed position. In fact, they vibrate about that fixed position. And so for the arrangement of particles inside of a solid, the particles are close to each other. So I just put close, they're close right here. And just to make a note that the particles are arranged in a uniform manner to give a regular shape or a fixed shape and also a fixed volume. All right, so generally particles are arranged very close to each other, all right, or in a specific shape. All right, so part 2 is to draw the arrangement of particles in water in the box. And so you're drawing typically for any given liquid. And so the particles are relatively close, but not extremely close, and they're not also far apart. So you're kind of in between. And so the particles are relatively close and can slide over each other. All right, so that question is out of the way now. For question number 3, is that the table gives information about atoms. And so you have number of protons right here, you have number of neutrons, you have number of electrons, and you have the symbol. And so for the first row, which is sulfur, you have a proton number of 16, so therefore the number of electrons must also be 16, because in an atom, the atomic number, the proton number, and also number of electrons, they're all equal. All right. Now for the second row, here we have Al3+, which is now an ion. To form an ion, electrons are either gained or lost. And so if you become a positive ion, which is a cation, that means you lose electrons. And so for aluminum, it has 13 electrons as the number of proton. However, losing 3 electrons, that's why it is 3 positive, then we have only 10 electrons, all right? Because the proton originally will be the same as the number of electrons. So losing 3 electrons the electron will become 10. Now for O2 minus, actually paper had O2 plus, but I just changed that to O2 minus to bring across a point as well, because the negative sign means that you actually gain electrons, right? And so oxygen start off with 8 protons, gaining 2 electrons, that's why I have -2, then the electrons will become 10. All right? All right. Now let's go to the next part of the question. And for part B, is a stated type of bond formed when sulfur and oxygen react. And when sulfur and oxygen react, you get here a covalent bond. And the reason why a covalent bond, because when two nonmetals react together, what you get is a covalent bond. All right, for part C, it states that aluminum is a very reactive metal, but is resistant to corrosion. Explain why this happens. And this explanation here, and this is a 3 marks. So what happens is that the outer aluminum atoms in the metallic lattice will react with atmospheric oxygen to form a protective layer. And so now this protective layer now will prevent corrosion from occurring. Why? Because the protective layer is now aluminum oxide, and this aluminum oxide will prevent further oxidation and also other chemical reactions. And so that is why it is really corrosion resistant. All right, so part 2 of this question now is that other than resistance to corrosion suggests 2 reasons why aluminum is used extensively in the manufacturing of airplanes. And so there are a number of reasons here. One, because it's lightweight, and of course things flying in the atmosphere, flying really to take off and all that, they really need relatively lightweight. Less fuel will be burning if it's lighter in weight and so on. Readily available, that's another one. It's relatively strong as well, so strong is another one. It is UV resistance and also relatively inexpensive comparing to durability and so on. The production may be really expensive, but durability and all of those things, it would be a little bit inexpensive over time. All right. Or you may say cost effective, and maybe that is a better way to put it, is cost effective, because again, corrosion free and all those, corrosion free, easy to bend, so it's malleable and all of those stuff. Yeah, we make it really, really good, a good use in terms of cost. Now for part 3, is a suggest another use for aluminum. And aluminum, beside making airplanes and so on, you can make pots with them or kitchen utensils. It can be used to make refrigerator frames, particularly used for cans, used to make window and door frames, and also to make foils, foil wraps, if you want to say foil wraps, right? So any of those will be decent answers. All right, so question number 4, it said this question is about physical changes. And it said the table shows the melting and boiling points of some elements. And I know when students see this type of table, they really don't like it. But we're going to go through it to see how best I can make you understand this, because I think these type of questions are giveaway, to be honest with you. But I know some students really don't like it for whatever reason. But anyway, let's run through it. It says use the table to answer the following questions. Predict the physical state of each of these elements at the given temperatures. Now, to make it easy, right? Let me just kind of point this out real quick. Melting point means that at this temperature, the substance is melting, which means it's moving from a solid to a liquid. At boiling, this is a temperature where the substance changes from liquid into gas. That's it. So the melting point is when it converts from solid to liquid. The boiling point is when it converts from liquid into gas. That's it. All right, so let's run through it now. So predict the physical state of each of these elements at the given temperatures. So let's go to it. So A at 0, okay? A at 0 degrees Celsius will be a gas. Let me show you why. Because minus 296 is less than 0, right? So it starts to boil already before it reaches 0. So by the time it reaches 0, it's already evaporating. So it must be a gas. All right, must be a gas. Now for B at 100 degrees, now watch this now carefully. At 100 degrees, it melts at 28, right? So anything above 28, it must be a liquid. However, for it to become a gas, it must reach to a point of 669. But it's only 100. So 100 is more than 28, and still less than 669. So therefore, it turns into liquid and it remains a liquid because it's still not evaporating at that time, right? So how easy that is. So that's a liquid. All right, let's go to C now. For C, and C is at 2,110, right? 2,110. So watch this now carefully. If it's at 2,110, again, it's above 1,535, right? That means it is a liquid at that time. However, it did not pass the 2,750. So since it did not pass 2,750, it is still a liquid because it turns a liquid at 1,535, and it can only turn a gas when it reaches 2,750. There's a liquid. Last one. For D at negative 10. If it melts at 32, anything below 32 will have to be a solid, right? So minus 10 is way less than 32. So therefore it must be a solid because it can only be a liquid at 32 degrees, right? So just watch the temperatures and know what the temperatures mean, and then you're good. Now for part B, it's a defined term, melting point. And melting point is a specific temperature that a solid is converted into a liquid. Or you can say it as this way, is at the point at which a pure solid and the liquid state of that solid are the same in terms of temperature. So once the temperature is the same and solid and liquid can coexist, then it is a melting point. Because point to note, as a solid melts, the solid and the liquid is the same temperature at that point. All right, so part C is to explain what happens during boiling. All right, and it said here to the temperature of the liquid and also to the molecule in the liquid. So in terms of temperature in the liquids, right, while you have boiling taking place, it remains the same. And because once the liquid is turned into a gas, the temperature is the same. So point to note is that when there's a change in state, the temperature remains the same. However, if there's no change in state and you apply heat, then the temperature will be different. All right, so here now, the molecules in the liquid. So the molecules in liquid, they start to move faster. Why? Because they gain energy, and that energy will be kinetic energy. All right, so the heat energy will convert into kinetic energy, and the particles will start to move rapidly. All right, and so in other words, a matter of fact, the way they move, the hotter particles will move up, and the colder one will drop down. So it cause what they call this convectional current start taking place. All right. So part D, which is the last part of this question, is state the difference between boiling and evaporation. And so for 2 marks, you're looking for 2 differences, really. And I guess, then again, I just mean this in a compound difference. So it's the boiling occurs throughout the liquid, while evaporation occurs at the surface of a liquid, or of liquids, right? The next thing here that is different is that boiling occurs at a specific temperature, while evaporation occurs at any temperature above absolute zero. So evaporation can take place at any temperature once it's above absolute zero, but for boiling to take place, the temperature must be very specific. Now, boiling do not cause change in temperature. As I mentioned, moving from liquid to gas, there is no change in temperature, while evaporation results in cooling. And how evaporation results in cooling, and this is kind of play trick on people's mind most times, but evaporation causes cooling because evaporation will take away heat from that liquid. You see? So just like when you're sweating and the sweat evaporates, it actually helps your body to become cooler. All right, question number 5. It said this question is about acids and bases. The first part of the question, which is part A, it said name the substance required for an acid to form hydrogen ions, which is H plus, in solution, and that is water. All right, so acids will dissipate H plus ions in solutions, and solutions generally contain what? Water as the solvent. All right, for part B, it's a write the name of an acid and a base that could be used to make the salt copper 2 chloride. And to make copper 2 chloride, you can use hydrochloric acid because you need the chloride in the salt. So notice the chloride coming from the hydrochloric acid, and you can use copper hydroxide. So the copper will go with the chloride to form copper chloride, and so use copper 2 hydroxide in fact. And so again, remember once you mix the acid and the hydroxide, you get salt and the water. All right. And so I put the formula beside each compound. All right, for part 2, it said write a word equation for the reaction between the acid and the base in B1. And so hydrochloric acid plus copper 2 sulfate will give you copper 2 chloride plus water. And that's a neutralization reaction. For part C, let me go up a little bit. So part C says magnesium and dilute hydrochloric acid react to give aqueous magnesium chloride and hydrogen. State 2 observations that could be made during this reaction. And once you're going to react magnesium with an acid, what you're going to get is effervescence, which means bubbles will be seen forming throughout the liquid or even the surface of a liquid, but bubbles will be forming. All right. So effervescence is what is this the phenomenon that is called. So you do not apply heat as in boiling. So different from boiling. No heat is required right here. And so for the next one is that the test tube becomes warmer. And it becomes warmer because simple is that is an exothermic reaction. So that's another observation. Warmer test tube or the reacting container. It could be a beaker as well or conical flask, depending on what you're using. But yes, it'll become warmer. And another observation that you can make, which now you have to do something to make this observation. If you should ignite the gas, then what you're going to get is a popping sound. And reason why, because when you react magnesium with the hydrochloric acid, you're going to get hydrogen gas. And hydrogen can be tested using a glowing splint, and it will give a popping sound. Now for part D, it said the insoluble salt, barium sulfate, is prepared by precipitation. Name 2 soluble salts that can be used to prepare the insoluble salt, barium sulfate. And so you have quite a number of options, 2 options for each. And so you can use sodium sulfate or you can use magnesium sulfate, but you need a sulfate for sure. So it can either be sodium or magnesium, right? And for the nitrate part, because again you're forming barium sulfate, so we have a sulfate part for for the barium part. To get barium, you can use barium nitrate or you can use barium chloride. So the top one will give you the sulfate part, and the bottom part will give you the barium part. All right. Now let's jump into another part of the question. And this is part C. Now part C says concentrated sulfuric acid has different properties to dilute sulfuric acid. And of course, it depends on now the amount of available H plus ions again, or the amount of particles within a given volume. All right. So you have less particles. If you're diluted, you have less particles per volume. If you're concentrated, it means you have more particles per volume, or atoms per volume. All right. So here now it said when concentrated sulfuric acid now is added to glucose, which is C6H12O6, steam is given off, and a black solid is formed. And so name the black solid. The black solid is carbon. And just to make a note right here that the water molecules are removed as steam. So the steam that is given off is actually water. And what remains is carbon. So a way to look at this is this way, right? Because if you look at C6H12O6, H12O6, if you divide it by 3, what you get is technically, because H2O6, if you divide this by 6, which means you have 6 water molecules in this technically. So H12O6 is actually 6 water molecules. Think about it. And then if you take out the water, which is the H and the O, what remains is just the carbon. Carbon is really dark black substance. Now for part 2, it's a state the type of reaction that takes place when concentrated sulfuric acid reacts with glucose. And what happened here is that the glucose will be broken down into water and carbon, so it is a decomposition reaction. Heat will be also given off, so it's also exothermic in nature, just to make a note right there, but it is a decomposition reaction. All right, that's question number 6. And this question now is said iron is extracted from the blast furnace, and please spend some time to go through it to make sure you understand the processes and the chemical reactions that are taking place in the blast furnace to produce iron. And so for option A, part 1, is the iron is extracted from an ore. Is to state the name and write the chemical formula of the main ore of iron that is used in the blast furnace, and this is called hematite. And hematite can be spelled either without the A or the A before the E, right? So whichever option you can use them. Now the formula is Fe2O3, and then for part 2 now, it's a name. Jumping a little bit too fast. So part 2, right? It's a name the two raw materials placed in the blast furnace along with the iron ore during the extraction process, and you're going to put coke in, and coke is pretty much mainly carbon. And the next raw material needed here is calcium carbonate, which is limestone. And then for part 3, it said name a waste gas that leaves the blast furnace. Mainly you get carbon monoxide and nitrogen gas, just to make a note right there. But of course, some amount of carbon will also be given off as well. Carbon dioxide, I should say. But carbon dioxide is also used in the blast furnace as well to maintain the conditions and temperature and so on. But you would have some amount of carbon dioxide coming out, but you'd have carbon dioxide, carbon monoxide, and also nitrogen gas. And of course, they will treat these gases to make it less harmful in the environment and also to human beings as well, because carbon monoxide could actually poison human in that it affects the blood, and the blood is unable to transport oxygen. Now for part 4, it's a slag is formed when sand in the impurities react with calcium oxide. And notice here it's a calcium oxide, and so sand with calcium oxide is a big giveaway right here. It's a stated chemical name for slag, and slag will be calcium silicate because sand contains silica. All right, and the calcium oxide, once silicon reacts with calcium and oxygen, you get calcium silicate in this way. So notice the elements present: calcium, oxygen, and from the sand you get silica or silicon, and so therefore we got CaSiO3. That's the chemical formula, but the name is calcium silicate. For part B, is that most of the iron made in the blast furnace is used to make steel. Steel is an alloy of iron, and it's a defined term alloy. And an alloy is really a mixture of elements where the main component is a metal. All right, and of course, that's why they refer to as metal alloy, because which means only metals are in those alloy. All right, so part 2 is a name another alloy of iron, and so let me see right here. So this one here will be cast iron, which is iron and carbon, because it's alloy alloy of iron. And just to make a note right here, I put some extra ones. These are not alloy of iron at all. So I put brass just for you to know the extra ones. So I should let me kind of color this one in red. So this one is the main one that we are actually looking for in terms of the answer. All right, so cast iron, all right, is made of iron and carbon. All right, so the others are just for you to know them. Bronze, which is copper and tin. Brass, copper and zinc. Solder is tin and lead. All right, so the fourth option here in red, that is the answer for this particular question. Now for part 3, it said, why are steel alloy used in preference to iron itself? And steel alloy, they are stronger than iron, and they are more resistant to corrosion. All right, and those two are the main reasons why you use alloy steel compared to just iron alone. Now for part C, it's a part of the reactivity series is shown. And so if you notice, sodium is to be most reactive and silver will be the least reactive. And it's a name one metal in the series that is reduced by zinc. And for them to be reduced by zinc, then therefore they must fall below zinc. And so copper or silver would be one of the options. All right. Now for question number 7, it said the percentage of carbon dioxide in air is 0.04%. It's a state given a reason how you would expect the percentage of carbon dioxide to change in a crowded classroom. And the classroom is crowded when people are breathing out carbon dioxide, then the carbon dioxide level or percentage must increase. In other words, now what the reason for that is because more carbon dioxide will be released due to an increased exhalation. All right? Because more people mean more exhalation. all right, in terms of the classroom. Now, part B is a major source of energy in the combustion of fossil is the combustion of fossil fuel. So, and they said here, name one solid fossil fuel, and we have two right here. Either be charcoal or peat. And charcoal will be the most popular one, of course. For part C, one is a carbon bonds with hydrogen to form hydrocarbon, propane. It's a draw the structural formula for propane, show all the atoms and all of the bonds. And so propane, prop, which is 3 carbon, and ane, which means only the single bond between the carbon. And so you have 3 carbons and the H's attached to them. Remember that each carbon will have maximum 4 single bonds. All right? All right, just to make mention of that. You can look around it to see 4 lines around each carbon. And no matter how you draw carbon compounds, it must be a total of 4 single bonds. Whether the combination be 2 double bonds, doesn't matter, or a triple and a single, doesn't matter, or 4 singles, really doesn't matter. It must see 4 lines or 4 total single bonds around each carbon. For part 2, methane can react with bromine. It's a state the name of this type of reaction. So if bromine reacts with methane, what you're going to have is that because methane is purely single bonds, then one of the hydrogen must be replaced with the bromine. So it is a substitution reaction. All right. All right. For part 3, it said write the word equation to show the reaction between methane and bromine. So bromine as a gas will be Br2. Methane is CH4. So one of the bromine will replace one of the hydrogen, and so you have the bromomethane and also the hydrogen bromide. All right, and so for part 4, it said alkanes and alkenes are both hydrocarbons. It's a state how alkanes differ from alkenes in their molecular structure. Molecular, which means just the exact number of each element. All right, so or atoms. And so alkanes will have 2 more hydrogen atoms compared to alkenes with the same corresponding number of carbon. And what that simply means, remember in the formula, because alkanes are CnH2n plus 2, while alkene will just be CnH2n. So therefore, there are always 2 extra hydrogen for alkanes for the same number of carbon in terms of alkenes. Now, for the last question, it said this question is about our food supply, and it said identify 2 benefits of fertilizers. And persons who do bio will love this question. And so, benefits of fertilizers, the use of fertilizers. Not saying that they're good in terms of our consumption, but good for the plants is that you will have faster growth, and actually, if you have faster growth, you have more production as well. So it could be faster growth is one, more production could be a separate point. Healthier plants in terms of the available nutrients are there for the plants. We're not saying it's going to be healthy for us to eat. No, we're saying the plants will be healthy because the plant will be exposed to the nutrients they need. You get larger fruits, tend to get larger fruits generally, and you also have increased production. All right, so yeah, faster production is different from increased production, which means you can have more in terms of quantity, and you can have faster processing in terms of less time to produce. All right. Now for part B, it's a fertilizers. Let me just go up before I start reading that. For part B, it's a fertilizers and animal waste in the form of nitrates can run off into nearby lakes and seas. This results in excessive plant growth and algal bloom. To state the name of the process that causes excessive plant growth and algal bloom, and this is called eutrophication. All right, and you can go and read up on that to make sure you understand exactly what it is. And so for part 2 here, say ammonium nitrate is a fertilizer. Name the substances that react to form ammonium nitrates. And so to get ammonium nitrate, you're going to need ammonia and also nitric acid. All right, and so I'm going to show you exactly well. Here it actually asks you, so write the chemical formula and calculate the relative molecular mass for ammonium nitrate. So if you notice ammonia and nitric acid, the H will come to this to form NH4, right? And the NO3 will be So it'll be NH4NO3. All right, and so that is the chemical formula for ammonium nitrate. The relative molecular mass is 14 for the first N, 4 for hydrogen, which is 1 times 4, 14 for the second nitrogen, and 48 will be 16 times 3. And so 16 times 3 is 48. And so add up all these numbers, you get 80 grams. And so 80 grams is the relative molecular mass for ammonium nitrate. For part C, so phosphorus is used in fertilizers. Why is phosphorus needed by plants? And phosphorus is needed for many things, but the major thing is for growth and development, to provide strength, to strengthen the plant, and also to produce energy in the form of ATP, because you notice ATP is adenosine triphosphate, and so phosphate coming from phosphorus. So phosphorus is very important to make ATP in plants. All right. Now for part D, it said pesticides are sprayed on crops. What are pesticides? And pesticides, they're pretty much any substance, right, used to prevent or control pests. All right, and so pesticides are really chemicals. And so some examples of pesticides, just to kind of give you the general idea. Insecticides, they will kill insects. Fungicides kill fungi. And herbicides, they kill herbs, otherwise called plants. All right, and so at the end of this review, I thank you for watching, and I hope you do well on your examination. Please, if you haven't done so, subscribe. Also share with your friends. All right, so take care, and I will talk to you soon.